Once again, I want to welcome all of you to the Valley of the Shadows of Management Science. As I indicated, the topic we're going to do, we're going to split it into two, the first part and the second part. The topic is known as time series forecast. Strangely enough, I've written the series double I instead of one. It's supposed to be one. Time series forecasting. By the end of this, you should be able to use methods of forecasting. Very useful for different time frames. You should be able to know how time series and regression can be used to develop forecasts. Forecasts that are made up of horizons of any length, short, medium, long, even though some of these time frames tend to be used most frequently for short-term and medium-term range forecasting. You should understand what forecasting components are. We're going to look at that. And then more specifically, for today, we'll look at moving average, weighted moving average, exponential smoothing. That is a simple exponential smoothing, and then adjusted exponential smoothing. Then next time we'll look at linear trend, seasonal adjustments, and then all the 4 different forecast accuracies. So let's begin, ladies and gentlemen. What is a forecast? Who can give me another word for forecast? Let's start with that. Who can give me another word for forecast? What comes into your mind? Give me as many synonyms as possible. Victor.
Predict.
Victor.
Predict. The word is predict.
Prediction. Okay. Maud.
Sir, please, projection.
Projection. Good. What else? Apart from prediction and projection. Abdul Rahman.
Speculate.
Speculation.
Yes.
Good. What else? Since we are using them in the form of noun, don't use the verbs. So when you think of the verb like project, you think more about projection. Predict, think more about prediction. Estimate is not a good word. Estimation is not. Give me another word for forecast. Okay, somebody has written foresight, which I kind of buy a little bit. Foresight. Okay. So forecasts. A forecast is a prediction of what is going to occur in the future. The future is very uncertain. A lot of the political party that was in government, they never for once thought they would lose for some strange reason. Whether it's in the US or it's in Ghana, the sitting government never thought that they were going to be kicked out. They could not use a proper predictive model to be able to detect the outcome. And so you need a forecasting skill. It's necessary. Is it going to be a boy or is it going to be a girl? Do you know that you can use forecast to determine whether you want a boy or a girl? I use that to get a girl, and then I use that to get a boy. Easy, if you know forecasting. If you want a boy as your firstborn, you ain't got a problem. If you want it as a girl as a firstborn, you ain't got a problem. There is a proper forecasting method. You got to know and apply. Then you can achieve that. Speculation is one as well. And of course, foretelling. So let's look at typical application of forecasting. You can use forecasting in several areas. Meteorologists use that to tell whether the weather is going to be hot or cold, and specifically the temperature. Sometimes they mislead us, sometimes they win. When there's a possibility of volcanic eruption, earthquake, all of these things related to, natural disasters. You use forecasting a lot because these are serious matters. We also use that to predict man-made factors like war. You can use forecasting. You can use forecasting in football, soccer, sports. A lot of forecasting is done there. Sportscasters predict the winners of football games. Managers, let's go to companies. They forecast future demand of their product. So let's say that you are producing something and waiting that this Christmas, there will be a lot of demand for this item. So you forecast, and on the basis of that, you produce that. During the COVID-19, many cars were grounded, but that was a period that Tesla price went up, and Elon Musk jumped to become the richest billionaire. How come? Forecasting. So as a manager, can you forecast when your demand for your product to be higher? I have now forecast exactly how my income will be like by December 2025. Beyond that, I have calculated a forecasting mechanism. And I know that that is not what I want. So I need to alter the dynamics so that I can improve that. You got to know and predict. And if you're comfortable with it, you keep forecasting. Now, these are beginning parts. So that's why I'm slowing down so you can get it. If you don't forecast well, it can lead to poor inventory. You will get some goods you are not supposed to get, and they will spoil when they are not supposed to spoil. You have to use this forecasting when you are staffing in your company. Do you need to employ assistant manager, or you can outsource, or you can use the one who is on the lower level to come up to the upper level? You can use forecasting for inadequate customer service. You can use it for customer complaints and all of that. Forecasting is very practical. Okay, now let's get into the nitty-gritties. Proper work. Managers are able to use forecasting in a form of judgment. They judge using forecasting. There's something we call the expert opinion, the Delphi method. It is a very powerful forecasting approach that tells the future using informed judgment and opinions from knowledge individual. So they do what we call a questionnaire. And then based on the questionnaire, you are able to now predict expertly about what's going to happen. Managers use that. They also use their past experience to do forecasting. So sometimes they come to the table and then they will tell you that, well, based on what we saw last year and last 2 years, and even last 10 years, I think we got to do this one and do that one and do that one. Past experience. But then all of these are kind of qualitative. Now we have technological forecasting. And even more powerfully, we have mathematical and analytical tools called time series and regression, which are used for proper forecasting. And ladies and gentlemen, that's what we're going to do today. So let's begin. Take your pen and your book and follow along. Don't just listen. You will never, ever be able to enjoy it, and you will not even understand it if you are just listening. But if you are writing, you're calculating, you're calculating along with me, you will understand what's going on. What are the components of forecasting? There are two main components. The first is the time frame. So forecasting depends on the time frame. That's the first thing. Second, it depends on the patterns. What do we mean by time frame? But a time frame is the planning horizon. And there are several of them. You can have a short range, which is usually 1 to 2 months. Okay. So if you want to predict something short range, you can do it. You can do it because it's short. Okay, so you can see a trend and then predict. For example, you are likely to be able to predict tomorrow than you are to predict next year. So that one is a long range. So whether you're going to be correct today by predicting tomorrow, you are likely to be correct in predicting tomorrow than in predicting next year. The weatherman is likely to be correct in predicting the weather for tonight than to predict the weather for 2 years. So the time frame matters. Okay? The time frame matters. Whether the frame is a short or medium term is also another thing. Medium term is 2 months to 2 years. And long term is more than 2 years. Stock market analysis uses a lot of long-term prediction or forecasting. What about the patterns? Well, the patterns are of 4 types. Whether the pattern is a trend, so the trend will affect you. For example, you may have seen a trend which is not necessarily a season. Okay, so the trend can affect the way you forecast. And a season, the season, and you see, sometimes people confuse a trend and the season and the cycle. The cycles is also another pattern. We'll look at them. And then finally, whether it's a random variation, it's happenings. Unexpectedly, there is something, then that something leads to that. There's no pattern per se, but it's actually a pattern because it's a noisy pattern. You know, for example, when there is an accident, unexpectedly, it is a pattern. It's a random variation. So what are these? Well, let's look at each one of these graphs, and the graph will tell us what each one is. The first graph is you are looking at the demand for a product over time. A demand for a product over time. When you look at the way the graph was rising, then it falls, it dips, boom. Then it rises again, okay? Then it dips, boom. Now there was a dip and there was a rise, as you can see it. And then it dips again, but it keeps rising, all of that. These sharp fall, the sharp rise, these are known as random fluctuations, random movements. What kind of pattern is this? The pattern is known as a trend. A trend. Now, why is that so? Because in a trend, you have gradual, long-term up and down movement. And it was true. You can see that you have gradual, okay, everything here is long-term, but then you have up and down movement. You can see little by little, up and down movement, up and down movement, up and down movement. That is what we mean by a trend. A trend. Now, do not confuse that with a D, the third one. We shall come back to the third one. Okay, we shall come back to the third one. But I hope that so far you get it. Okay, the next one is, let me see what someone has written. Okay, the next one is what is known as a cycle. You see, when you look at a cycle, it's not rising. It's not rising consistently. You know, if you look at the trend, it's rising consistently, but then there's a dip. But then a cycle, it rises and falls, then it rises and falls, and the net effect is that it's not rising. So that one is not a gradual long-term up and down movement. No, it is up and down movement, repetitive movement. Up and down repetitive movement. It's not, you know, up and down movement and then it's gradual. No. And so you should be able to distinguish between a cycle and a trend. Then you have season or seasonality. Season is just like a cycle, yeah? But the only thing is that it comes at specific moment in time. And those specific moments in time is what is causing that. I'll give you a typical example of a cycle. A cycle is that you know that you're going to go to bed, you're going to rise, you're going to bed to bed, you rise, go to bed, you rise, you go to bed, you know, you have morning, afternoon, evening, like that. But season, you have up and down. It is also repetitive, but it's within a trend. And it occurs periodically. It's within a trend, and it occurs periodically. Now, what do we mean by is within a trend? Well, we know what a trend is. Whatever is happening in a seasonal pattern is inside a trend. You still have up and down, up and down, up and down. However, there is a pattern which is as a result of a season that you have control over, or a season you do not have control over. And then you can mix it all, okay? And that is the last one, which is known as a trend with a season. Well, you know what a trend is, as you can see. You know what a season is, as you can see, A and C. A trend with a season is just a trend, as you can see. This one is just a trend, that's number one. But then the season are inside a trend, so it's rising. And so you cannot attribute this to Christmas, no. Unless you have a situation to say that at Christmas, every year, there's something that is happening, and whatever is happening is increasing. Okay, then you can see that. For example, some time ago, there was this HD glasses where you wear and you can watch TV, or you even 3D glasses also. And you can watch TV, or you even go to the cinema and they'll give you this 3D. Do you guys remember? What happened to them? Now they are no more. Okay, they are no more. Where will you have placed that? They are no more. It just come, and that will be a typical example of noise. Okay, that's a typical example of noise. It's a non-continuous thing. All right. So those are the things that can influence what is known as forecasting. Those things that I've mentioned, the time frame and the pattern. Never forget that, the time frame and the pattern. Now let's look at the methods you can use to do the forecasting. Suppose you want to forecast whether demand will be higher or will be lower. Well, the first method is time series. Time series is a statistical technique. And what it does is that it uses past data to predict future behavior. Simple. I'll put it this way. It uses past behavior to predict future behavior. Write it down. That's a time series. It uses past behavior to predict future behavior. What it does is that it assumes what has occurred in the past will occur in the future. And it is purely based on time. So what has occurred in the past over time, as to whether certain things can affect it, okay? No, this one is saying that time is what is affecting it. Over time, it will affect what will happen in the future. That's time series. That's not the same as regression, because regression establishes a relationship, what we call causality. Regression is a causal relationship, okay, that has a variable called a dependent variable, and that variable is being influenced by an independent variable. And the marginal effect of that independent variable on the dependent variable is what leads to the causality. Let me explain what I mean. So you have a variable like quantity demanded. Let's say the quantity demanded of a certain commodity, iPhone. And this quantity demanded is a function of, or it depends on the price of the iPhone. Now, if iPhone is considered as a normal good, then an increase in the price of iPhone will reduce the quantity demanded of iPhone. Suppose your current iPhone you're having right now, and you are going to get the same thing and they tell you that the price has gone up, you are likely to cut down your purchase. So in this case, what is the dependent variable? The dependent variable is the quantity demanded. So the quantity demanded is said to be the dependent variable because it depends on the price. And the price is said to be the independent variable. This is a mathematical relationship. And in this context, you can now say that, okay, now that I know the price and the price is, say, $40, what will be the quantity demanded? Because now I know the price. And that is what regression looks at. We look at it, use it for prediction. And then finally, the judgmental one, qualitative one, okay? Qualitative methods, okay? Where you are using judgment, based on past experience, past opinions, past expertise. You are forecasting. Normally, that is not that much reliable because you can always fail. So we're going to take the first one and look at the different aspect of time series there are. Let's start with the first one. And please get your pen ready. The first one is known as the moving average. You get a question on this. What is a moving average? Watch the word moving. Watch the word average. So it means that an average must be calculated. So what it does is that if it wants to predict tomorrow's demand, it uses recent past demands. It uses recent past value to predict future value. And you will understand why it's called moving, because what it does is that it dampens or smoothes all the randomness. Okay? So it smoothes out random rises and falls in the data. And that makes it a moving, because it's an ongoing phenomenon using the past values. So using a particular number of past values, you can now predict the future value. So it's like you're using the past to guide you. It's very, very powerful because if the data is stable, if the data doesn't have a lot of fluctuations in it, okay, then what's going to happen is that this one will help you. It will help you big time. So this is a formula for the moving average. I want you guys to write it down. In fact, another way of writing the moving average formula is just saying MA, moving average, for a particular period, okay, where the number of period is the n, is going to be the sum of the individual demand divided by the periods. That's the moving average. Write it down. Write it down. And when you are done, please type Y. Some will not write. That's why I want you to write and type down. So now that you've written, what does it say? It says that take each demand, sum them, and divide it by the number of period. The number of period can be months. The number of period can be days. The number of period can be years. Doesn't matter. Okay. And then the D is that particular data point. Let's take an example. Okay. This is an example. You have a 10-month data on product orders. And this data is for a company known as Instant Paperclip. This paperclip supply company. Your question you are to address is, look at the November. We don't have the orders for November, but looking at the demand, the orders, we want to forecast for November. And we want to use a moving average. What kind of moving average forecast can you use? Well, there are quite a number of them. And each time you'll be told exact moving average that you look at. We want to use a 3-month moving average forecast for November. What does that mean? It means that November, if we want to predict the value for November, and by the way, look at the bottom here, okay? If you want to get a value for November, we don't have it yet, go backward 3 months. That's what it means. And they use the average of the 3-month orders given the time period, and then you solve that. Who can tell us the answer? I want to see the smartest person among you. Who can tell us the answer? Or who can tell us how to go about it? How do you do it? How do you do it? Who can talk? Dinah, how did you do it?
Okay, so I added August, September, October, and then divided it by 3.
Correct. So what you do, guys, write it down. What she said, write it down. You're listening to her, you're not writing it down. So if I want to do MA, and the period I'm doing for is 3 months, then you're going to take the 3 months before the November, okay, in the order in which they are. So let's say you have 90, that is the closest one. Then the next one is for September, which is 110. Then the last one is August, which is 130. Then you divide it by 3. And that is what gave her the answer. If you don't know, write it down. See, you won't write it down, but you should. That's when it sticks. It only sticks when you write it down. So that is how you do a 3-month moving average. Who can do a 5-month moving average? A 5-month moving average. So a 3-month moving average, November orders is going to be 110. That's what it means. So November order will be the same as the September order. Who can tell us a 5-month moving average for November? So instead of going, past by little, this time you're going the past by more. Who has gotten an answer? Who is the smartest among you guys? Okay, so I'm going to give it to Victor. Victor, tell us how you got that. Oh, no. Victor has not raised a hand. Sorry, Victor, don't bother. Harold, tell us how you got it.
So from June, I added 50, 75, 130, 110, and 90 divided by 5. And I had 91.
Okay. Now, even though what you said is correct, I told you that you should add them from what? Instead of saying I added 50, 75, you should have said I added what? Who knows what I mean?
From the month of October.
From the bottom.
Yeah,
From the bottom, listen to what she's saying. From the closest month of November, then you rather go backwards. So always remember that. So this is the 5-month moving average, and that gives you 91. Guys, is that not easy? At first, it looks like Hebrew, but now by looking at the example, you can see that it's cool, isn't it? Okay. So now let's go to the next one. Now, what I decided to do was to do all of this in Excel. So I'm going to go to Excel, and then I'll show you how, in fact, I've given you the data. Okay. So this is the data set. Yes, Kweku. Yes, Kweku.
So the 5-month moving average. I thought you were gonna add November to it, since we know the forecast for November.
No, that forecast for November was a 3 month. It was a 3 month.
No, okay. So I'm saying that we have done the 3 months and got
Yeah,
the
but you cannot
figure
use 3
for
months to do 5 months. They are complete different time horizons. What you are
All right.
doing is that you are rather doing a 3-month moving average, and then you do a 5-month moving average, which is independent of the 3 months. Remember, both
All
of
right.
them are being used to predict November one by one. Each one is trying to predict November. You can do a 2-month moving average, a 4-month moving average, a 5-month, a 6-month, a 7-month. How do you do this in Excel? These are the orders. And you can see that November is not done. So I'm going to go to this right here and say that I'm going to do a 3-month moving average. So I do N is equal to 3. Okay. Then I'll also do a 5-month moving average. So I'll say N is equal to 5. I'm going to do for each one of them. And like I said, they are not related. Okay. So how do you start? To do this, you go to Data tab at the top. On the far right, you will click Data Analysis. Okay. Data Analysis. And then in the list, you see moving average, and then you select moving average. Okay. We just want to know what will be the order for November. Okay. And then we are taking a 3-month moving average or 5 months. So let's do 3 months first. When you do 3 months, this is what you get here. The first thing you want to do is to select everything. Select everything. So highlight everything. Click on the input range. Highlight everything from orders up to October, because we don't know November. And include the heading. If you include the heading, then select labels in first row, because you have included the heading. Then with the interval, select 3, type 3, because we are doing a 3-month moving average. The output range, choose the output you want to use, where you want to place them. And the output should be from here. Okay, you click on 1, the January. So I'm going to click on this section here. And then you can now take chart output. So chart output will graph both your forecast as well as the actual data graph. You're going to check both. Oh, you always have to start from what do you call it? From period, because we are doing 3-month moving average. Okay. Let me just delete. You're doing 3-month moving average. So you got to start from period 4. We are doing a 3-month moving average. So the first 3 period, you ignore it. So let's try it again. Okay. So you have to jump this period. Period 1, let me just highlight it for you. Jump period 1, jump period 2, jump period 3, and then start from period 4, because you are doing a 3-month moving average. So you have to ignore the first few ones. So let's go back and where your cursor will place. Okay. So the result, you want the results to be located at where your cursor will place. So the cursor is going to be placed at this section here, April. So that's where I want to click for my output range. Then you can click OK. Did I do the right thing? Yes. It is. Oh, no. Oh, goodness me. Let me just quickly correct it again. So you have to start from period 2. Okay. You start from, always ignore the first period. Because remember, you are forecasting and you should have the past, and the first period didn't have any past. And so you just have to start from the second period. So once again, let me just go back here, click OK, and just put the cursor in your second period, which is February here. Perfect. So this is your forecast. Okay. I'm going to show you the graph and you see what is interesting. By the way, the graph, the blue one is showing you the actual forecast. That's what the blue one is doing. That's the original data if we're to draw a line graph. And then the orange color, okay, shows you the forecast itself. And we started from, it's a 3-month moving average. So you can see that the graph is indicating from data point 3 or period 3. And you can see that generally it is below, especially after period 7, it is below. It is rather above in the first few. But the most important one is the forecast for November, which you all got. What it's done is that it's ignored this first 3, okay, because you started from 2, which you should. And then the forecast has been done for every month, but our interest is for November. So you can see the November forecast is 110, which most of you got it. Let's look at if the moving average was not 3, but it was rather 5. If it is 5, the same thing, you click data analysis, click moving average, select 5 instead of 3. Choose the output range, and this time we're choosing the output range in period 2, again from February, okay, so that I will start from that period. Where is that? Okay, and then you click OK. And there you go. Okay, most of you had 91 for November, and you can see that November is also truly 91. The 5-month moving average is 91. Now look at these two graphs. There's some slight similarities and differences that I'm going to show you. Okay? And that's how you do it basically in Excel. So let's go back to the results. So this is our results that we have here, and you can see that November is 110 moving average, then 91 moving average. This is a graph for each one of them. The actual one is the deeper one. The 5-month moving average, look at it carefully. The 3-month moving average is here. Look at that carefully. There's something between the two, and that's what I'm going to show you. First, longer periods moving average react more slowly to changes in the demand than shorter period moving average. Okay. And you can see that from even the results. Look at longer periods moving average. You can see that especially towards the end, okay? Especially towards the end. But where is that? So look at the actual one, and look at the difference between the 3-month moving average and then the 5-month moving average. Especially towards the last one, you can see that the 5-month moving average is slightly reacting, slowly. Because if you look at October and November, the 3-month is bigger than the 4-month. Okay, the 3-month is bigger than the 4-month. That's the first point that we've indicated. The second point is that the appropriate number of periods to use is a try and error. Okay, why are you using 3 months? Why are you using 5 months? Why didn't you use 6 months? It's a try and error. It's a try and error. At the end of the day, next week you see, at the end of the day, you will see that we'll calculate the error involved in each. And the one that gives you the greatest error is discarded. The one with the smallest error is the one that is taken. So you can use 2-month moving average, 3-month moving average, 4-month moving average, 5-month moving average, and then for each one, you can calculate the error. The one with the greatest error or the one with the smallest error is selected. So it's all right to do try and error, okay? And then you can take the one with the lowest error. Another point you should notice that the moving average does not react well when it comes to changes. Okay? Changes like trends. So if there are trends in the data, if there are seasonality in the data, the moving average doesn't react well. But it's very cool. It's easy to use. We just did it. It's not costly. We just did it. So that's really, really cool. That's cool. The next thing is that it is very good for short-term forecasting, not for long-term. Okay, if you're doing a lot of stock market work and you go and use moving average, you're going to struggle. It's for short-term And finally, if the forecast is for a period longer than 1, okay, you can see that in our case, it's longer than 1. Then the forecast, like November in our case, the forecast can now be used as actual data. So you can use the forecast as the actual data to calculate the forecast for the next period. So you can use the forecast for November to replace December. Okay. However, once the data becomes available, okay, then you can go back and then rather predict December. Okay, that is all. That's all you got to know about moving average. It's simple, it's easy. There's another one. The second one is weighted moving average. As the name sounds, what you are doing is that you are assigning weight to the most recent data. Look at the formula. It's very simple. Weighted moving average, you still have the period N. The W here, as for the sum, don't worry. The sum here is simply talking about adding summations, right? Sometimes when people see this, they get scared. There's nothing. So what you are doing is that you assign some weight, and the weight is normally between 0 and 1. So you assign some weight, say 0.3 or 0.45, a certain weight to each order, each demand, before you what? You sum them. Okay? You assign the weight, you multiply the weight by the orders before you add them all together. So let's take an example with our example. Let's say that you know the weight. Okay. Let's say that you know the weight, and I told you that the weights sum up to 1. Let's say that paperclip weights. What they've done is that they've weighted the orders for October to be 50%. They have weighted the orders for September to be 33%. And they weighted the orders for August to be 33% and 17%. Add all of this together and you see that they are 100%. With the weight assigned, and remember we are going to predict November. So I need to now be able to now find the weighted moving average, given these weights. And I know the orders. Okay, what are the orders? If you go back here, okay, these are the orders. The orders for September, I'll write it down. The orders for September, because you're going to calculate. The orders for September are 90, sorry, for October are 90. For September is 110. For August is 130. So 90 from the bottom, 90, 110, 130. And these are the weights. Okay. These are the weights assigned to each of them. So 50% for October, which was 90, 33% for September, which was 110, 17% for August, which was, I think, 130. Who can tell me the weighted moving average for this that we are going to use to predict that of November? Who is the smartest among you all? Who is the smartest among you all? I always need one person who is dancing along with me. This one you can use it. Yes.
Can we say 33 because it is in between the.
No, listen, you've done it wrong. Your question clearly shows that you probably done it wrong. You just take the weight, multiply the weight by the demand, the orders, and then you sum them. It's simple. It's simple. And I told you what the demands were. Okay. October. I've got somebody. Somebody has just got it. Dinah has gotten me the answer. Dinah, how did you get it?
Okay, so I multiplied October sales 90 times 0.5, and then September 110 times 33, and then August 130 times the 110 times 0.33, and then August 130 times 0.17.
Perfect.
Then I sum them all up.
And you wrote the correct answer, and they can all see the correct answer you wrote. You are the kind of people should get to know. You are the kind of people, Dinah, that people should befriend. not the ones they are befriending. That's it. That's it. That's how you calculate the weighted moving average for that. And when I tell you, as long as I give you the weight for any particular month, you should be able to calculate the weighted moving average. We are building from the smallest, so we are going to the higher level. So if you understand this, you'll be fine with the others. Let's go to the next one. Exponential smoothing. That's the next one. Exponential smoothing. What is that? Well, it's an averaging method. Okay. It also assigns weight, but it assigns the weight to the recent past data. So looking at our analysis, our example that we've been doing all this while, who can tell me the recent past data? Which period is that? Which period is the most recent past data? Which month? Let me see whether somebody, it's October, good. And the other day was what? What was the order? Because it's not a period we are looking at, it's the data is excellent, Dinah, 90. Okay. You see, because she wrote it in using it for the previous work, she already remembers it. Yeah, great. So what you do is that the weight you assign to the recent past data is you assign more weight. In other words, you put more importance on the recent past data than the distant past data. Okay, that's what you do. And so we are going to look at how you do there are two of them actually. Okay, there are two of these approaches. Now the question people tend to ask is, how do you get a weight? Well, the weights are computed automatically and become smaller and smaller, as observations move further and further into the past. So the further you go, the less important it is. Why is that so? Practically, why is that so? That is so because, come on, guys, what is happening today can happen tomorrow. Than what happened, last 2 months can happen tomorrow. The weather is likely to continue from the past, unless you are in the British weather, which is very unpredictable. But the nature of the weather is closer in days than in weeks. That is why the recent past data is given more importance. That is more weight than the distant past data. I hope you guys get me. You guys are smart, so I know you get it. So what are the forms of the exponential smoothing? And you will understand the meaning of the word smoothing, because the opposite of the smoothing is the dampening. But there are two forms of the exponential smoothing forecast. The first is the simple, the second is adjusted. We'll do these two and we'll be done for today. Simple, adjusted. Which one do you think is easy? Which one do you think is easy, the simple or the adjusted? If you guess wrongly, you are wrong. If you guess correctly, you are right. There's a simple, Victor, that's correct. The simple is easy. Okay. So let's start with a simple exponential smoothing. This is it. This is a formula for the simple, and please write it down. This is a formula for the simple exponential smoothing. Write it down, write it down, write it down, write it down, write it down. Imagine you are driving and listening to me. It means that you're not writing it down, and that means that it's going to affect you. Okay. So this is a simple exponential smoothing formula. What does each item mean? Well, look at it carefully. The word T plus 1 means that is the forecast. That is a forecast value. That is the value we are looking for. Okay. So normally that is the first information you want to know. Is a forecast for the next period. Now, T means the current period. T plus 1 means next period. And please remember, period is not always years. Period can be months, it can be days, it can be hours. The next period. So if I want to know the next period, what do I have to do? I have to put some weight and the weight is an alpha here. I'll come back to that. I have to put some weight on the current demand, and then whatever the weight is left, I'll put it on the forecast for today. So I must have the forecast for today and give it a weight as well. And you know that I will give more weight to the current demand than the forecast for today, because that is a kind of a forecast, or the current period forecast. Okay, because that itself is a forecast. It's not actual. But then the current demand or the current value, that one is visible to your eyes. So that's the first thing. So D is the actual demand in the present period or the current period. And then the previously determined forecast, but for the present period, that is a FT. I've said this already. And then finally, the smoothing constant is the alpha. That is the weighting parameter. That is the importance you are attaching to a particular, value, whether it is a current or present actual demand in the present period, or it is the previously determined forecast for the present period. Okay. That is it. And alpha is that weighting, is a smoothing constant. So with this, we are going to take a simple example and then see what will make sense. But I want to put a cautionary note here. If you look at the future forecast, the previously determined forecast for the present period, for example, the forecast for today, which you are supposed to have determined from yesterday, and you use that to determine, you have the forecast for today. Because we don't know the forecast for today, the forecast for today or the forecast for the present period will always be equal to the actual demand in the present period. This point is very important. When we come there, okay, you have to write it down because you need that. So the forecast for period 1 will always be equal to the demand or the actual demand for period 1. Okay, so just take note of that. I'm just taking my time to explain this formula because when we start applying it, now, how do you even get the alpha? Again, that is by try and error. And remember, if you choose alpha equals to 0.1, then 1 minus alpha is 0.9. If you choose alpha to be 0.2, then 1 minus alpha is 0.8. If you choose alpha to be 0.3, 1 minus alpha is 0.7, and on and on and on like that. This is done on, track. So if it is an exam, for example, then that particular alpha to use will be given to you. So when you are told that alpha is 0.6, you should know that 1 minus alpha is 0.4. Then you can use it for the rest. Let's take an example. You see, the previous one was a different data set, and I want to use a different data set. And this is called computer service, PM computer services. What they do is that they assemble customized computers from generic parts. And what it does is that it puts the computers assembles them mostly at night from a lot of sources. Whenever they see a good deal, they assemble it. And they want to develop a good forecast of demand for their computers. Why? Because they want to know how many computer component parts to buy and then to stock. And it's accumulated a lot of demand for his computers for the past 12 months. So if you look here, okay, for the past 12 months, these are the demand. Okay, that is the estimated demand, actual demand they've had over the past 12 months. But they want to also know that of January, because they have it from January to December. They want to know for that of January, and they need your help. And they are asking you to do this for them. Okay, they want to compute the exponential smoothing forecast, and they want to do that for February and for March. And then, of course, later for all the months, including the January. Okay. So they want to do that for this February and March. As for January, we know it already. Okay, they want to do it for February and for March. And then they want to do for all the other months so that it will go into the next period of period 30, which is January. So they need your help. And they've told you that the constant alpha is 0.3. And then when you're done with 0.3 for all of them, change the alpha to 0.5. Those are the smoothing constants. So we're going to do 0.3 first for February and March. Then we'll do 0.5 for February and March. The rest are easy. It's just your understanding which is key. So don't forget that the constants are 0.3 and then 0.5. How do you start? Remember the formula first. Now, what would you think would be the forecast for the current January? What would be the forecast for January? Who can tell us? Not the January at the bottom. I'm talking about the January at the, not at the bottom, but at the top. What would be the forecast for that January?
37.
Again?
37, sir.
37. Very good. Very good. You are listening. So the forecast for January will be 37. So we don't even need to do that. That is why it actually said I should start from February. So if I were to create a column, and that column is FT plus 1 for January, is going to be 37. Okay. Now, this is a formula that you are going to use. Let's calculate the forecast for February. And we are using 0.3 as a smoothing constant. Do that. Who has finished? We are using 0.3. All right, continue. I said you should walk us through how you got your answer. Start.
Okay, sir. So the FT plus 1.
So what will I write
And in
here? What will
this-
I write first? What do you think I should write? I'll write F what?
40.
No, subscript what?
Subscript 40 plus 1.
No, it can't be subscript 40 because I'm looking at what I'll write here for this. What would that be? Who can help him with that?
I think this is where we need to determine FT.
Just
equals
mention the
BF.
number. Just mention the number.
Oh.
It's a period. It's just a period
37.
I'm looking for here. Okay, that is what I'm going to write. What?
F2. F2.
What are you saying that I can't even hear all of a sudden?
F2.
So it's supposed to be 2. It's a period. You're calculating for period 2. So that's what you write. Okay, continue.
Okay, sir. So that will be equal to 0.3
Mhm.
times 40
Times 40
plus 1 minus 0.3,
which is
0.7
mhm.
times 37.
Good. That's it. That's all. And that will give you the forecast for period 2. It also happens to be the answer that you have given. So for those of you who are not following, that is how you solve for that particular one. In fact, you should have 37.37. Did you all get 37? Or you got 37.9?
37.9, sir.
Did you actually calculate from your calculator?
No, sir. It's 37, sir.
Yeah. And you are all giving me wrong answers. Only Franklina got the right answer. Only Franklina. Harold, no wonder Harold, or you are struggling. Okay? Harold and Salam and Franklina came to copy them. Dear me. She wrote a correct answer, then she was confused and came to copy them. Anyway, that is how you find this. Double check to be sure of where you are. And that is because they are all 37, 37. Okay. Remember, we are looking at we are forecasting for February. Okay. And so the demand you use wasn't, did I write 40? It shouldn't be 40. It should be 37. Okay. The demand is the current. That is, or let's say previous. Okay. Previous. And so that is DT. DT is January. And we are forecasting for February. Okay. So that gives you 37, 37, 37. So take note of that. Now you go to F3. Okay. But I don't want to go to F3. I want to change the smoothing constant to 0.5. If it is 0.5, what would that be? The smoothing constant is 0.5. And you are still calculating for February. What would that be? Let me see whether somebody is going to crack that. You are still calculating for February. Are you guessing, Christopher? If the smoothing constant is 0.5, I just want to be sure that you know what you're saying instead of guessing. Okay, so that's correct. Okay. If you do for February for 0.5, you're going to get 0.5 into 37, 0.5 into 37, and you're still going to get a 37. Okay. So that one is good. That one is just like, you know, halving the 37 and adding them again, and you get 37 back. Let's do the forecast for March. Yes, Salam.
Please, I want to find out why the DT and the FT are both 37.
Why the
DT, D subscript T, and then FT.
Okay,
Why they are
so
both 37.
remember that the DT is the January demand, which was already given to us, isn't it?
Yes, sir.
So that one we don't even have control over it. Now the FT is the forecast for January. But then before you can forecast, as you can see, we are forecasting for February here. As you can see, if you are forecasting for January, if you're writing the thing, watch it carefully. If you're writing, it's going to be FT. If you're forecasting for January, it's going to be FT, then alpha DT, and then 1 minus alpha, the past. And this past is FT minus 1. Okay? So you're going to have the past forecast because you are doing for this. Now, we don't even have the past forecast. We don't even have the past forecast, which is December forecast, which is behind us. We don't have that. So this value is not there. It's 0. And then when you look at the current forecast here, DT, and by the way, because we don't have that of this and this one is 0, you cannot put a smoothing factor for DT. You cannot, because you don't have the other one. So you can't apply a smoothing constant for the current. So it simply means that the FT, the forecast for January, is going to be that of the actual demand for January. That's it. Because you don't have anything in the past to use to be able to, it's like the past is the present for January. Because everything we have in our hands is 37. That is where we start from. We don't know anything from the past which can be used to predict January's forecast. Does that make sense?
Yes,
Let me go to Selim. Does that make sense before I move on to Dede?
yes, sir.
Okay, Dede.
So with the past, information, why can't we put 0 there? Because we don't have it. So why can't we put 0 there?
Okay, let me ask you. If you want to predict something for tomorrow, you only thing that you have is to use that of today. That's it.
Right.
You have to use what you have today. You got to assume that what you have today will happen tomorrow. You can't say, I don't know what will happen, because your job is to forecast in the first place. And so that is why whatever, and again, we are not looking at even tomorrow, we are looking at today. What is the forecast for today? It's like asking me, how old are you today? How old am I today? How old am I today is my year for today. Or how old am I this year is my age this year. But if the moment you ask me how old am I next year, I will just take this year and do something with it this year, add some things to it, and then I'll get to my age next year. But how old am I this year is this year. It is there. It is there right in front of you. It's a now. That is why the forecast for the present is the same as the demand for the present. Abdul Rahman.
Yes, sir. So if we have a case where we have to work out for March, does that mean the FT? So after 1 minus alpha, FT will be the value for January.
You got it.
37.
No,
Okay,
you're going to use the value you had
yes.
for February, because you would have gotten a forecast for February.
Yes.
So when we are in January, sorry, when we are doing for March, okay,
Yes.
this value here is
Yes.
going to be the
Will be for
February
January.
value.
Oh, February. Okay.
When
That's
we
if
are
I'm
doing
working
for
out for
March,
March.
yes.
Yes.
When we are doing for March, this one,
Yes.
because when we
Yes.
are doing for March, FT is February's value,
Yes.
February forecast value, which we just did here, which is 37 here.
Yes.
That's what we are going to use. And then the DT, as for the DT, you have it there already. Okay. The
The
DT
DT
is
will be
what?
41.
41, exactly.
Okay.
So that is how you compute the value. We did that. Okay, we did that here.
Sir,
It is a
sir,
41.
please, just so
Yes,
I'm,
go
I'm not
ahead.
mistaken, if I'm not mistaken, you see, we have for when we're working for February, it says period
Sorry.
period 2.
It's not
Yes,
41, it's 40.
it's 40. Yes, sir.
Yes, it's
Yes, sir.
40 because D1 is for January. So remember
Yes,
that
sir.
when we are forecasting for March, we are actually
Yes.
inside January.
Yeah.
And so because we are
Yes.
inside
Okay.
January, this is what
Yes.
happened. When we are forecasting for March, this value here will become February
Yes.
value.
Yes.
And this value here will become
Yes.
February's forecast. And what we are doing is we are looking for March forecast here.
Yes.
So when we are forecasting for March, okay, you're going to have F3 equals to alpha D2,
Okay.
which is February, and then
Yes.
plus 1 minus alpha F2.
Okay.
And that will mean that you're going to have 0.3 D2, and D2 is what, 40, plus 0.7 F2, which you would have calculated. So if your calculation here is wrong,
Yes.
this one too will be wrong. And in this case, it's 37.
37. Okay.
And then you now find the answer by using your calculator. When you do that, let me show you here. When you do that, you're going to get 37.
All right. Okay. Okay. So the only exception is for January, where we have so under when we so if you look at this data set, January would qualify the use of F1 equal D1. But once we've moved past January, then let's say alpha D1
No.
F.
What you're talking about is February.
Yes.
What you're talking about is February.
Yes.
In fact, let me correct. something.
I'm just trying to understand something, saying that if we have a question that has to do with working out.
So let me share. I think one lady asked this point, and I want to just address that. And in fact, she was correct. The value for January is unknown. The forecast for January is unknown.
Yes.
The forecast for February will be January.
So we understand. I'm just trying to say that because it's unknown, that is where the rule F1 equals D1 will apply. However, once we move past that, so when we move to February or March, it means we have a forecast for previous. So that rule doesn't apply anymore.
Exactly. That's what I was trying to get at. Perfect.
Okay. Thank you. I understand.
Yeah. The rule doesn't apply anymore because now you have a forecast value. And on the basis of that, you can calculate a forecast for all of the rest that are there. Okay. Now, so that is for March. Okay? On the basis of that, you can now calculate for all of the rest. And then by the time you get to December, you would have known the value you would have used for January. Yes, Maud.
Sir, please, you said that after calculating with the 0.3, we should also try it with the 0.5.
Oh, yes, you can do that.
Yeah, so when you calculate with the 0.5, you get 38.5. But for the 0.3, you get 37.9.
You are right.
Subsequently, when you are calculating for F4, do you use the 37.9
no,
or the 30?
When you are starting, do 0.3 all throughout. I was just saying that you're going to do 0.3 all throughout, and then when we finish, we do 0.5 all throughout.
Oh,
it's not do this one, do this one, do this one, do 0.3, then do 0.5. No. Assume that there's no 0.5 when you're starting. You are going to just use the 0.3 smoothing constant. Forget about 0.5. In fact, you can see that I've even stopped looking at 0.5. And finish everything from January to January. You get it? Then let's assume that the smoothing constant is no longer 0.3. Alpha is no longer 0.3, but rather is what? Is 0.5. What would the whole results be? So you have a result here. You have this result where alpha is 0.3 for this one. Then you have all the answers here. Then you have another one where alpha is 0.5. Then you also have a result for all of that. Does that make sense now, Lord?
Yes, sir. Thank you, sir.
All right. So when you do that correctly, you're going to get all of this. So you can see that here, you have alpha being 0.3, and you have here alpha being 0.5. That's basically how you calculate for this simple. Remember, the word is even simple. Exponential. If you don't understand the simple, you can't understand adjusted. So it's very important you should understand the simple. Yes, hello.
Please, I want to find out if this can also be done in the Excel.
Sorry?
Can we use Excel for this calculation?
Yes, you can. Let me show you. Let me go to the Excel. Okay, so I think I have the data set. I was trying to be sure that I have the data set. I think I have. So this is a data set that I have here. And you see, you know that this data set is different from the previous one. So I'm going to take this one, put it here, then we do it together, then you can appreciate it even more. So there's a data set. And look at the bottom, you will notice that we don't have for January. January is empty. Okay. I'm going to assume that alpha here is equal to 0.3. Okay. That's what I'm going to do. Alpha is 0.3. And what I'm going to do is you click on Data tab, then you choose Data Analysis, and you choose Exponential Smoothing. It's a simple exponential smoothing, but they didn't write simple exponential smoothing. They wrote exponential smoothing, but it's the same thing. Click OK, and then let's highlight the entire data. That's the first thing. So I'm going to highlight the entire data and also include the heading up to December. Then here, you have something called dampening factor. Dampening factor. Please, the dampening factor is the 1 minus the alpha. So in Excel doesn't rather give you the alpha. And no, it doesn't even give you a space for you to write the alpha. It rather gives you a space for you to write the 1 minus the alpha. So just keep it in mind. The dampening factor is the opposite of the smoothing factor. So the smoothing factor is the alpha. The dampening factor is the 1 minus the alpha. So we are using 0.3. So in this case, the dampening factor will be what?
7.
0.7. So that's what you type here, 0.7. Okay. Then you take the label, because when we're selecting the data, you added the labels. Then you indicate where you want your output range to be. And we want the output range. We know that January is not going to be there, so we are going to do the output range to be the next one, starting from February. I also want to draw the chart so that we see how the chart looks like. So you click chart output, and then you click OK. Oh, I should have started. No. I should have started from, I should have actually clicked January, because it would take January to be unavailable. Okay. So let's do that. I should have clicked on the section for January, because January will automatically be unavailable. So let's do that. So click on January here and click OK. Good, perfect. Now you can see that you have the results. You can see that February is 37, March was 37.9. Are they the values we got? Yes, right? And when you click on each one, you see that the calculation was done 0.3 multiplying the February value plus 0.7 multiplying the forecast value, which, you know, he called it F3. We have not gotten the January yet. So at this stage, to get January, you just go and click here, watch it, and just drag it down. Just drag it down, because whatever formula is here is going to be here. So click here, drag it down to January, and you will know the January value. The January value is 51.79. What is it calculating? When you double click inside, you will see that it is taking the demand from December and the forecast from December and using that to calculate the January forecast, which is it. That is how you calculate. And you can do for the 3, for the alpha equals to 0.5. In that case, the dampening factor is 0.5 and the smoothing constant is also 0.5. Director, do you understand? The one who said, can we do it?
Yes, sir.
Okay. And again, you can see the graph. There's something about the graph you can see here. You can see that the actual forecast is about, sorry, the actual value is about the forecast all through and through. Generally, the actual is about the forecast. When we later come and look at the other one, you'll see that the adjusted is better than the simple. Oh, by the way, I've just done for 3. Okay. I've just done for alpha equals to 0.3. You can also do alpha equals to 0.5. Let's do that quickly. I'll just copy this one, drag it here. Okay. Just change this one to 0.5. Just go and click the data analysis, change this one. All you got to do is change this 0.5. The dampening factor will also be 0.5. And then selecting where you want the results to be. You want the results to be here. So you start with the first one here and click OK. And now you can see that for 0.5, you have this. If you want for January, you can just drag this one down here. Okay. Just take the first one, the last one. Just drag the last one down here, and you'll get the forecast for January when alpha is 0.5. Now you can see a bit of a trend between 0.5 and 0.3. Watch something. Each one of them, you can see that 0.5 is bigger. 0.5 is giving bigger forecast. Bigger forecast. Bigger forecast. You check for each period, 0.5 alpha is giving you a bigger forecast than the 0.3. So the bigger the alpha, okay, the more likely the higher the forecast. The higher the forecast. Let's go back to see all the results here. So in here, you can see the point we just made. Okay. So I've given you all of the results. You can do it one by one and check it. But I just don't want you to be so comfortable with Excel, because you will not use Excel in the exam room. You will also have to understand what's happening by hand. Once you get past the first one, the rest is as it is. So the first conclusion is that the 0.5 reacts more strongly, and you can see it generally. The 0.5 reacts more strongly in demand than the 0.3 does. So the 0.3 changes in demand are higher, you know, but for changes in demand are higher for the smoothing constant 0.5 than smoothing constant 0.3. Okay, that's the first observation. The second observation is that, and you can see it here, you can see that both forecasts lag behind the actual. Look at the actual. The actual is 41 for March. Okay, the 0.3 is lagging behind the 41. The 0.5 is also lagging behind the 41. And it cuts across all through. So if you look at December, it's 54. 0.3 is lagging behind is 50. 0.5 is lagging behind is 53. So both of them are lagging behind. But you can see that the 0.3 is really lagging behind more than the alpha, which is bigger. The next point is that both forecasts tend to be consistently lower than the actual demand. I think I've said that. Okay. Both forecasts tend to be consistently lower than the actual demand. And then finally, the one with the lower smoothing constant, they are usually good when the data is stable without trend. Without trend, and I'm sure by now you will understand trend. Okay. But when there are trends in the data, then the alpha being bigger, a bigger alpha is better. It's appropriate for data that have trends. Okay. Bigger for data that have trends. Of course, if this was in an exam, okay, and you're hand computing, I'm not going to give you all of this for you to calculate like that. No, that you will die. Okay. So I'll just give you everything, fill in all the rest, and I might say that calculate that of the first two. Yes, Salam.
Yes, sir. Please, the 0.2, that's both forecast lag behind the actual. It's not the case for the month of April.
Sorry?
So special. The 0.2 that says both forecast lags behind the actual demand. It's not the case for the month of April. Is there like a peculiar situation or?
Oh, no, general. It's general.
Yeah, but if you see April.
Yeah, but April is typical. I'm saying April is typical, but this is general. Generally speaking, okay, speaking, these forecasts generally will lag behind the actual. Are you getting the point?
Yes, sir.
All right, okay. Generally, not in all, periods, but generally.
Yes, sir.
Okay, so that is simple exponential smoothing. We are going to the last one for today, and that is the adjusted exponential smoothing. It's the most difficult one, but it's also the coolest one of all. Okay. By the way, the 0.3 and the 0.5, these are the graphs which support the conclusions we made. So let's look at the adjusted exponential smoothing. I'm calling it AESF, adjusted exponential smoothing forecast. Okay. Adjusted exponential smoothing forecast. Now let's move on. Adjusted exponential smoothing is an exponential smoothing forecast with a trend adjustment factor. Remember, we indicated that the simple one is very good when you don't have much trends. What if you have trends? Then when you have a trend adjustment factor added, then adjusted exponential smoothing is good. This is a formula. Write it down. Write it down. This formula is simple, but the details are not that simple. Okay, now all of a sudden people are joining back. This formula is simple, but now the details are not simple. What does the AFT plus 1 mean? What does the FT plus 1 mean? What does the TT plus 1 mean? Well, as for the FT plus 1 and TT plus 1, we know them from the previous. What we don't know is the AFT plus 1. The AFT plus 1, the A is adjusted. Okay, it's adjusted forecast. But before we can explain the T plus 1, the TT plus 1, the one on the far right, you should remember what T is. I mean, T for the present period is. The T subscript T is the exponentially smooth trend factor for the present period. It's exponentially smooth trend factor for the present period. And the T plus 1, the one on the far right, it is coming from what we did previously. It is T plus 1, which is equal to beta, and please write this formula, is the beta, and again, this is also a factor. Okay? It's also a smoothing factor, or a weight. A weight attached to the difference between the present forecast and then the next period forecast, or better still, the previously determined forecast and the present forecast. So if this one is the previously determined forecast, this one becomes the present forecast. And this one, the difference between them is weighted, and then the rest of the weight is given to the past or the current trend. Because remember, there's a trend adjustment. Okay? That trend adjustment is what you are adding to it. So what are the contents of this? The T plus 1, the T is the last period's trend factor. That was mentioned at the top here. That is the previous period's trend factor, which means that this T plus 1 will be the present period's trend factor. Okay. And that present period, the rest we know them because the rest are all coming from forecasts we have already calculated and all of that. But then now we have a certain beta attached to it here. This beta is a smoothing constant, but because we have a trend, it is a smoothing constant for the trend. It's also between 0 and 1. It tells you the importance given to the most recent trend data. And this is determined by judgment, your experience subjectively. Okay. So that is the value that you will have for this. So what this means is that before you will normally calculate this adjusted smoothing forecast, you must have done all the simple ones that we did. That's it. If you have a beta value which is high, is what it means is that the trend changes more. That's what it means. The trends are changing. So sometimes you can have a trend there. You can have a trend like people go to Makola a lot, people go to Makola a lot, but then the trend is changing. Okay. For example, there's this kind of belief that the moment the Democrat will win, then the NPP will win. The moment the Republican will win, then the NDC win. There is a sort of a trend, but the trend can change more. And we used to think that maybe a particular region, say Ohio, is a undecided state and that kind of thing. But now they are leaning more towards this. But the trend can change. And that is what I mean by the trend. When the beta value is high, then you mean that the trend is changing faster than when it is low. Okay, so we're going to calculate adjusted. And to calculate adjusted, you must have the forecast, the simple ones. So you can see that we have all the simple ones here. And we are going to use a situation where, and please take note of what I'm showing you here. We are going to, for this calculation, we are going to assume that alpha is 0.5. So the previous one where we use alpha is 0.3, and I told you that ignore the 0.5. For this one, let's assume that the 0.5 have been used. So whatever value we are going to use the values that are under the alpha equals to 0.5. So alpha equals to 0.5 is given here. And a new trend factor, a new smoothing constant for the trend factor has been given, which is 0.3. So you have that one here, okay, which means that 1 minus beta is going to be 0.7. Okay. With that in mind, here comes our question we want to address. There's a question. Oh, I'm supposed to have something before. Yeah, this one. Okay. So the first thing is that you need an initial value of the trend factor. What I mean is that you need a T subscript T, an initial value for the trend factor. And the initial value is 0 because you don't have the trend factor for the present. You don't have, because you've not calculated anything that has been adjusted yet. So the T trend factor is 0. The next thing you need is to remember that, and we've said this before, that the forecast for the present period is the same as the forecast for the next period. And that is also the same as the trend factor, which we have already said above here, that is 0. Okay, so when you are actually calculating this one for period 2, which is February, let's go here. If you are calculating this value for period 2, watch it. You are calculating adjusted exponential smoothing forecast, or better still, adjusted forecast, AF. If you are calculating adjusted forecast, you must know the forecast. And remember, this one is F2. So you must know this one is AF2. So you must know F2. And F2 is 0. Why? Because we've set it down here. Because T subscript T, or T1, is 0. And T1, which is 0, equals F1, which is equal to F2. And this is F2 here. Okay, this is F2. So F2 here is 0. And this point is made down here. So I just wanted you to note before we even proceed. Okay. So F2 is 0. F1 is 0 because it's coming from T1. T1 is 0. Okay. T2 is 0. And therefore, AF2 for February is 0. You got to understand from the formula. And again, when you go to the formula, you will see that. Okay, because if this one is 0, watch it. T or T1 here is 0. Everything here is 0. Okay. And FT is also 0. And FT plus 1 is also 0. And so because they are 0, and by the way, in case you don't know that they are 0, look at them here. You see them here. Okay, this value here, 0. This value here, 0. And because they are 0, then we'll have 0 for February, adjusted exponential smoothing. I don't want to calculate that, but I want you to understand that. Okay, so understand that parameter for you to know why AF2 is 0. If you slot it into the formula, I mean, you can go back and slot it into the formula, and then you can appreciate it. You want to find this, because see, watch this here. This one here is this. You need to find that first before you come and substitute it here. And this one, when you find it for February, it means the forecast, okay, for January. And then It needs the time. Where is the value here? Let me just show you something. You need the forecast for January, which is 0, okay? And that is T plus 1 here. T plus 1 forecast, and you can see it at the top here. T plus 1 forecast is 0. So T plus 1 forecast is 0. You don't even think about, sorry, FT plus 1 is 0. So you don't even need to think about T. No, even FT plus 1 is 0. So how much more FT? So FT plus 1 is 0. FT is 0. So everything here is 0. So T plus that is 0. So this one here is 0 for the first period, for the February. And we've already proven that this one is already 0. This FT plus 1 is already 0. So that one is the same thing that is here. So if this is 0, this is 0, then for period 2 for February, 0. Okay, I've repeated that 3 times. So you guys are there and you were not actually showing up. And then for some reason, we are all showing up right now. Okay, so that is for T2. So T2 is going to be 0. We've already established that. Let's go to adjusted forecast for period 3. When we do for period 3, you will now appreciate it. Before I take my roll call. So for period 3, remember we are trying to calculate, for period 3, we are trying to find this, okay? We are trying to calculate this one. Okay. So actually, what we are trying to do is that we are trying to find AF3 equals to F3 plus T3. That's what we are going to do. But first, we need to find T3. And T3 requires us to use this formula. Okay. So T3 will require us to have beta, and beta was given to us as 0.3. 1 minus the beta was given to us as 0.7. Okay, cool. What about FT plus 1 and then FT? Well, let's go down. You see it. If you look at the table, you see FT plus 1 is there. Okay. So you will substitute this. So we are doing T3, which is beta F3, F2, and then 1 minus beta T2. So what is the F3? F3 will come from here, okay? And we know the value of F2, and we know the value of F3. F2 is this. It is the previous one, which is 37. And please remember, we are using only this column here. So F2 is this one for February. F3 is this one for March. So you substitute that F3 value, you substitute that F2 value. As for the betas, we have been given as 0.3 and then 0.7. And what is T2? Okay. Now, for this very example, we were told from here, we've already established that from down here, that T2 is 0. The time trend, okay, is 0. And so you substitute that, and that gives you 0. So when you take the simplification value for this, you're going to get that. Let me do that. I'm just doing for the first, for March. Okay. When you simplify, you multiply 0.3, 38.5 minus 37, you're going to get 0.45. That is a T3. But once you get that T3, remember, what we are actually looking for is AF3, which is equal to F3 plus T3. Okay, so we got a T3 here to be what? To be 0.45. So you substitute that value there. What about the F3? Well, the F3 is here. It's coming from here. Okay, so you substitute that. You now add that one to it. So you're going to have 38.5 minus SR plus 0.45. And that will give you AF3. Okay. Let me show you. So that is this. You now get this value. You add these two together, and that will give you AF3. So this 38.95 is the adjusted forecast for period 3. you should do adjusted forecast for period 4. All that you are going to need, if you want to do adjusted forecast for period 4, is going to be AF4 equals to F4 plus T4. That's it. Okay. And that T4 must be calculated here. T4 here is going to be beta, okay, F4 minus F3, okay, plus 1 minus beta, okay, then T3. And you already have your T3, which you would have calculated. You already have the F4, which you would have calculated already, and then you can now use them to do your further analysis. So that is how you find adjusted exponential smoothing. It's a very, very systematic way. It's just understanding the formula and now using. And this part here, you should keep that in mind. Okay? This part I've written down here on the left, you should keep that in mind. The key point is knowing this formula. So you can see that you will now be able to have the adjusted exponential smoothing, which is the last one here. 4.5, don't forget, it's 4.5. Okay, you get that. And we're calculating for March. So March will be 38.95, which we did, and we got that. And then you can now find for the rest, and you can easily be able to work for the rest. The most important thing you want to remember here is that the adjusted is consistently higher than the simple. And you can see that here. Okay. This is a time trend, okay, which you would have calculated because the time trend is calculated separately. We had this one to be 0.45. Before we use that we added that time trend to the forecast value. Look at the simple one. This is a simple one, and this is adjusted one. They are the same. The simple and adjusted. Adjusted is higher. The simple, adjusted is higher. The simple, adjusted is higher. The simple, adjusted is higher. So you can see consistently, even up to January, simple, adjusted is higher. So the adjusted is higher because it's reflecting, the general increasing trend, because there's a trend. Is reflecting the general increasing trend of the data set. And that is how you calculate adjusted exponential smoothing forecast. Now, we'll solve some past questions on this, okay? If you become a good boy and a good girl, okay, I'll solve some past questions of this so that you can appreciate this more, because there are several questions that you can answer on this. As for the moving average and the weighted moving average, they are so easy. So sometimes there's not that much of questions on them, but occasionally you get. But exponential smoothing, simple and adjusted are the key ones. Next time we are going to look at regression, how you can use regression to do your forecast. Ladies and gentlemen, that brings us to the end of the entire caboodle.